Good morning, everyone. Welcome to this Tech Talk. Our community manager, Helena, is not here today, so I will be taking over the moderation. Yeah, will do my best to live up to the expectations. Yeah, so we have Tech Talk number 34 today. As always, the session will be recorded, and we will share it on YouTube afterwards, so you can send it to anyone who cannot join today but wants to take a look at the talk. I will not take too much time. Just the agenda is as always. We will have a talk, and then if it's fine for everyone, then we will have the discussion, questions and answers at the end of the talk. Then we can share some news and events. If any of you have anything to share, then get ready. You can also share your news or anything that you want to make known here. And yeah, we will just give you some information on the next talk. So today we have Marc Schöchlin from UhuruTec with us, and he will be presenting their open source project uMon, and will be sharing with us how it can be used to run standardized observability. And so yeah, we're looking forward to your talk, Marc. I will not add anything else. I will just stop sharing my screen and will give you the right to share. No.
Now I have the right. Just a moment. So welcome to my presentation of our new open source project called uMon. It's great to have you here. Over the next 50 minutes, I give you an overview what we have accomplished yet so far and what we have planned for the near future. So let's get started. So I will guide you a little bit through our approach, our principles, our base infrastructure, and so on. And the first thing we have to ask is, what is observability? Observability gives you an idea of what is happening, what went wrong, why is it happening, how can I fix it, how can I change it, did I solve it, what was it like in the past, what will the future be like. We see observability as a measure of how well you interfere the internal state of your cloud system by using the knowledge of external outputs. So what should you know after this talk? After this talk, you should know what is uMon, what are our good general goals for observability, what are our goals for uMon and why are they beneficial for you, and how has the project progressed so far? What is the technical design of the solution and what are the next steps and what is missing? So, hot take. Observability is easy. Just purchase and install fancy software and the rest will magically happen. If you look at the promises of the big players like Grafana, Datadog, AppDynamics, Splunk, and so on, you get the impression that it's, well, not quite that simple. So if we look, I've seen a lot of misunderstandings in the observability area in my career. Here's some examples. Dysfunctional misunderstandings of observability. Observability is often thought as mainly a visual issue because in presentations, that is typically what you see. And observability is often taken as a creation of fancy dashboards seem to be the main work. It's important that you have operation status screens in your engineering office to always see what's happening, to keep your services available. And sometimes observability's character is heavily influenced what management thinks of dashboards. So another facet is often observability is mainly understood as a question of tools and instruments. And often the idea is the amount of data and dashboards which is available determines the quality of observability. Another topic is there's in your organization there are rarely discussions about processes, approaches, and strategies. That's also a typical anti-pattern. It's very tool-centric and very signal-centric. Also, a silo mentality is something which goes wrong in many organizations. Only a few people truly understand the observability stack, its capabilities, and how it does it work. And another topic is also that licensing costs, security, and compliance requirements limit the growth and completeness of your observability solution. So, what can we do instead? So our approach is, from my experience, good guiding principles include that there is no universal observability solution on the market. There are many solutions, but for different aspects, you need different solutions, and typically a technology SOO is needed. Therefore, integration is key. A second topic is what we should keep in mind is that observability is an ongoing project. It's an ongoing engineering topic. Observability is never complete. The requirements and the challenges are constantly changing. So it's really important that you really understand what you measure and how do you measure. So understanding the architecture and business functions of your observed applications is key. Because of the fact that you are investing a lot of knowledge transfer and engineering to such a product, migrations are very painful. If you decide in a 2 or 3 rhythm to change your observability solution, that always pose a risk and to the production operations, because it ties your limited staff resources, and it carries risks to misunderstandings and a lack of necessary skills for the new platform. So if you have a very powerful observability solution, it's really important that you do consistent transfer of knowledge and concepts to the teams which are using that platform. I mean, not only the operations team which uses the platform, also the application development or other groups in your organization which use the observability stack. They should think of observability as an essential part of their products which they deploy. Observability is a decision-making platform. It helps you to understand the past, the current situation, and the future of your platform. And the most important topic is that you really have to trust your observability platform, because if you don't trust it, it's useless, and you're doing a lot of engineering, and you are wasting workforce. So alerts must be reliable. It's really important to constantly fight alert fatigue. What is that? Alert fatigue describes the state where engineers become desensitized to alerts. Reasons for that are excessive, noisy, or low-value notifications, or also no notifications. And that, if that appears, that causes that important issues are overlooked or ignored. So it's really important that you work with your observability system every day, and you improve your alerting system every day. So when we look at observability, there's a traditional classification of observability systems. If you look at the SRE handbook of Google, there is metrics, logs, and traces. That is a typical classification. But you can also look for it at a different perspective. The purpose of observability should be the dominant orientation for building and running our observability system. So who uses your observability stack? Naturally, the on-call staff, which keeps the platform running. Also the engineering to find out things about the running platform, and also the management who needs that observability platform to understand if everything goes in the right direction. Why are you doing that? Because of service operations, you are doing planning and reporting, and you are doing product and technical research to make decisions for the future development of your platform. So when we change that perspective, we describe these three pillars as operations monitoring, application and system analytics, and application and system profiling. You see the three pillars at the right and typical use cases which are processed in that pillar. So let's look a little bit deeper in it. So if we look at operations monitoring, on the figure on the right side, you see the typical use cases. If you look at operations monitoring, it's typically the first point of contact for most of the topics in the organization. Every analysis or every topic almost starts there. Its character is that it performs periodic measures, evaluates rules, creates events, and provides graphs and dashboards for the recorded data. Often, it is often an aggregation of other observability systems, and its main purpose is to provide a high-level service state overview. It therefore, the keyword aggregated, not in detail. It alerts on problems and manages escalations. Escalation is something like if a problem appears for a longer time, it's important to do the communication in the company or in the organization. It coordinates on-call operations and integrates with tickets. That's also a really important topic, because if engineers are starting to fix a problem or to analyze a problem, it's really crucial that they coordinate each other, that not two different engineers are trying to solve the same problem. It helps you to understand the past, predict trends, and the growth. It's a long-term storage for KPIs like service level indicators, service level objects, and service level agreement. That's the traditional description which you can see in the Google Site Reliability Engineering Handbook. And this is also important for extrapolating the future behavior of your platform, and also looking back for some topics. For example, what happened when we extended a platform, and what effects can we see then there? Examples for operations monitoring system are Zabbix, Izinga, Datadog, Mimir, Prometheus, Tanos, Grafana, Alert Manager. That are typical systems in that pillar. So the second pillar is application and system analytics. It collects events from specific sources created by service activity, and these events are basically implemented by the developers of these technical platforms, by the OpenStack developers or also application developers. They are creating, for example, log messages or events which are submitted to that platform. Basically, it's log data, events, and audit data. A typical situation is, a typical character is that such a platform stores structured JSON documents, stores structured log documents. Standardized properties enable cross-source analysis. What do we mean with that? For example, a thing like a request ID or a pod name or something like that are properties which are added to these documents. It provides ad hoc data analysis for answering new questions. You have typically a dashboard or a possibility to query the application and system analytics database to find out new facts about your platform. It provides predefined dashboards as a starting point, and it also provides queries as a function for operations monitoring. So you can do periodic queries to that application and system analytics solution to create new aggregated statistics. Typical representatives for that kind of solutions is Loki, OpenSearch, Greylog, Lockly, Splunk, Grafana and Kibana for dashboards or OpenSearch dashboards. A specific member is Sentry, which is a Arab aggregation system, but it's also in that class of systems. So the last pillar we want to discuss is the application and system profiling. Application and system profiling provides you a detailed view derived from the implementation perspective, from the implementation of specific services. And in contradiction to the previous part, it provides the ability to do dynamic creation of implementation and technology specific measurements. So you can apply new measurements to an already running platform and find out new things. It adds also identifiers to the activities, and it helps to understand the distributed execution of system functions. For example, SQL queries which are performed by an application which passed ingress controller of Kubernetes with correlation and with that identifiers, you can follow the entire call graph with traces and spans. These are the ingredients to achieve that. It basically performs function measurements by sampling. So it measures the time and can collect information from the execution. What I mean with sampling is that it does not record every activity on the platform, because that is very performance critical. So, for example, it collects only 5% of the requests and creates a statistic significance from that. It also provides ad hoc analysis and drills down the dashboards and drill down facilities for dashboards. Typical members of that pillar are Jaeger, Zipkin, Dynatrace, AppDynamics, Deepflow, and so on. So let us look to what should uMon be like. Our idea for uMon is that uMon is a suitable solution for cloud operators, engineers of that platform, and on-call staff. It's definitely targeted not for small organizations. It's targeted for organizations with 2 or more data centers with at least 100 physical nodes in their data center. It provides observed entities for hardware monitoring, switches and servers, and the Linux operating system, OpenStack, the Ceph storage system, and Kubernetes. It's a product for businesses where reliable and secure operation is a commodity. What do I mean with that? It's not a differentiator to other competitors in the market. Reliable and secure. When reliable and secure operations is your commodity, then that is the right solution, because it also provides or also needs collaboration with other users of that platform. I come to that point later. Organizations share operation knowledge as a strategy to counter the dominance of hyperscalers. What do I mean with that? If you are running a cloud platform, there are the huge hyperscalers, they like AWS and Azure and so on, and they have enormous teams to do observability. With a solution like uMon, you can exchange and improve your observability. You can exchange your knowledge and improve your observability stack between organizations, and you can build with that a situation where you probably can compete with the hyperscalers in some areas. It's also the right solution for organizations that view participation in open source projects as a strategic advantage. And the use of open source software and focus on sovereignty as a strategic goal, then this is also the right solution for that, for you. With uMon, you can take advantage of standardization. You can the work which is already done in the project is helpful. So you have a ready-to-use solution for open source cloud environments. You have releases and quality assurance provided by the project. So the entire testing and all the things which need to be done for quality assurance are provided by the project. You have a high quality implementation which for infrastructure and observability mechanisms, and you fulfill typical certification and compliance requirements with that platform. We started to build, or we built that platform to keep all the certification and compliance requirements in our mind and to develop and to integrate them in the platform. We are not at the end, or we have not fulfilled everything thinkable, but we are in a very good shape. Will come to that point later. You are getting predefined processes and concepts for on-call emergencies, migrations, upgrades, and application operations. And it's easier to provide support assistance for such a setup when the observability capabilities are known and visible. So if you are working in, for example, in a Yahoo ecosystem, then you know that specific alerts, measurements, dashboards, and so on are already available, and that is very useful. So when we look at collaboration, that is also an advantage. There are two main facets which are really, really useful. There is a community of practice. You become aware of, understand, and avoid known problems together. You reduce the time to resolve issues because you have the right measurements and the right concepts to monitor your platform. You have built-in capacity planning facilities, not yet, but in future. And you are fighting alert fatigue together. And you have the ability to compare the behavior of systems because all the users of uMon are using the same alerts, measurements, and so on. If you contribute as an organization to uMon, that also helps you because you have qualified discussions about your current problem domain. So you have with GitHub issues or with GitLab issues, you have the ability to do an exchange with other engineers of other organizations and to find the right solution to build the right observability. You get quality assurance feedback for your implementations. That is very often also not the fact if you do an in-house implementation, and you can leverage the long-term support of the solution. So you hand over your solution to the project, and the project takes the long-term maintenance for that. Your engineers gain knowledge and establish a knowledge network. That is also a very good thing. If your engineers are involved in such an open source project, then you have good opportunities to find the right person to solve problems. So the last advantage I want to mention is that there's someone who takes care of your long-term goals. If you have complex tasks, complex implementations, you have the ability to offload them and do a crowdfunded or do an offloaded project or a crowdfunded project for complex development projects. That ensures that development focuses on the product goals rather than context-dependent details. A typical nature of running an internal observability platform is that you are working from a hot topic to another hot topic, and you don't have the time to have a product development perspective on that. You have we have insights from various other usage scenarios, and it's easier to identify the right solutions. And a product management for that project also provides the possibility to balance capabilities, complexity, future-proofing, and flexibility. Requirements from different scenarios drive a modular distributed integrated solution. So it's not only a solution which is suitable for your organization because of the usage in different areas, the product gets more abstracted, modular, and so on. And we are ensuring the long-term maintainability of the solution. So that was the theory, and now we are looking in the concrete base infrastructure. We spent some months in implementing the current state of uMon, and our learnings so far are open core is a popular business strategy in the observability or open source area. Grafana stack, I'm looking at you. If you look at the typical Grafana stack, it looks very promising. But if you look in enterprise features and access management and many other things, you are seeing that you are very quickly in the situation that you have to use the payware product. Common open source observability solutions are often not enterprise ready out of the box. They are very flexible, but not enterprise ready out of the box, because many of the developers have not in enterprise environments not in their mind. Integration between products is often not so good. Features in the compliance security domain are often not that are often immature, and automatic and unattended upgrades are often incomplete or inconsistent. We are also faced with many naive Helm chart implementations, many Helm charts in that area. When you deploy it, you see that's very easy to get them running, but to implement all the requirements for advanced environments, you often see drawbacks which need to be solved upstream. So there are significant difference in community and defect management practices when we look at the various products we want to use. And many products lack good default configuration or guidance for complex, scalable, and highly available developments. We also see that open telemetry is on the horizon, but it's currently not very widely adopted. Many of the things I described for open source products also apply for commercial products. But in contradiction to commercial products, you have the possibility to solve these problems in open source products or find good ways to solve them, yeah, with configuration, for example. So when we look at the current state, we reached the minimal viable product in February 2026, and the entire implementation is a GPL v3 license. Contributions are very, very welcome. We are using Kubernetes as our basic runtime platform. So we prefer community Kubernetes operators over plain Helm deployments. We implemented the apps of apps pattern to do efficient Argo CD deployments, and all the features the solution provides can be activated or deactivated per target environment. We also implemented networking or transport encryption, mostly compliant for penetration testing requirements, and we developed concepts for managing stack upgrades. We did a lot of upstream work to address interoperability or functional issues. Some of the features are still pending, but we are making progress. And the core infrastructure is currently deployed in a pre-production environment. We're also using that for our own production platforms, and we implemented a specific data processing for Yahoo and Kubernetes. Also, the other aspects are already processed, but not in that depth or quality we want to do that. We also added single sign-on integrations for many of the products or for many of the solutions in that stack, but we haven't finished that yet. So let's have a bird's view on the deployed stack. This is what the architecture looks at as a whole. We will now take a closer look at some parts in the following slides. But as you can see on the left, you can see an exemplary cloud data center where OpenStack and Ceph are running on Kubernetes. It also provides the monitoring of servers and switches. On the right, you see the central observability infrastructure of that platform. It supports a distributed deployment. You can have multiple environments, availability zones, data centers, networks, and satellite systems. If you look at the diagram, we have here some nodes which are observed, and in the middle we have a caching buffering layer, which provides independence to the central system. And on the right side, we have that centralized observability infrastructure, what we need. We also have some ideas how to integrate ticket systems or shift management systems, but that is a topic of the future. The entire setup supports push or pull data submissions between these two stages, between the production or the observed platform and the central platform, totally encrypted and authenticated. The observability data can be consumed by multiple stages. That's also an interesting topic. You can have different centralized observability installations, and you can use these installations to provide services for different teams, or you can use it for doing transparent failovers or for doing transparent migrations between huge configuration changes. We implemented these proxy patterns for efficiency and security. So now let's look into the details of the operations monitoring platform. Here you see a diagram of the operations monitoring. It basically consists of the observed nodes. The nodes run a Prometheus exporter, and there are service and pod monitors which do basic Prometheus data scraping. We also have a SABIX2 agent on these systems. Both systems, we are using a combined setup for the operations monitoring solution because both systems have their strengths, and we are leveraging the strengths of both systems. So with the SABIX agent, you can have you can have things which are not that easy when doing that with Prometheus and vice versa. We also provide the possibility to do offsite monitoring, for example, for service availability or for reachability of the proxies. We are using for mass and floating name metrics. For example, if you're in Kubernetes, the pods are changing the names very often or always. We are using Mimir and Prometheus for that. and that observability platform is a long-term storage for the SLR, SLO, and SLI data. That's basically stored in Zabbix. Zabbix is also the instance which performs the alerting and the escalation, and Zabbix is also the solution which is used for humans to interact, for example, in on-call scenarios with the observability platform. It's the central central point of information for operations monitoring. If you want to do in-depth analysis, you can use Grafana to inspect the data stored in Mir and Zabbix, and we now will see some facts regarding the operations monitoring platform. We are using Mir. It's preferred over Thanos and Prometheus. Mir is an API compatible solution to Thanos and Prometheus, and it provides superior performance for scale out, and it also provides multi-tenancy in contradiction to Thanos and Prometheus. It uses Kafka for data ingestion and uses a local TSDB for the young data and S3 buckets for long-term storage. The second part of that operations monitoring platform, as I described, is Zabbix. It provides also superior performance because it includes a timescale DB plugin in the Postgres database, which supports you to store and process billions of data sets. It's clustered. It provides long-term storage for your data. Zabbix provides the operational workflows like silencing alarms for specified time or forever, alert claiming, escalation of alerts, defining and coordinating maintenance things, and there it provides a history which helps you to understand how often an alarm, for example, is triggered and in which situations. It provides also multi-user support in contradiction to classic Prometheus setups. It allows you to do tenancy separations. You can change permissions for specific areas of the system. It provides auditing. That's very important. It's important to understand when which person changes the configuration or performs operations like a maintenance or something like that. And it provides multi-environment support. A very, very good thing in Zabbix is that it provides ad hoc fine-tuning. If you bring new operational new monitoring mechanisms in production, it sometimes acts in another way that you expect. And it provides the possibility for engineers to fine-tune the configuration or the logic of alerts. And this is also in the auditing, so it's very easy to understand later what happened in the system. It provides a huge protocol support and extensibility and flexibility. Also in contradiction to Prometheus, it provides more flexible data types, textual data states, that's, for example, for batch jobs, a very interesting thing. It provides dependencies between data types, and it provides calculated and scripted metrics. You can do in Zabbix things like interacting with an OpenStack API to test periodically things like the creation of a virtual machine. We also implemented that in a custom area. It provides API automation, templated automation, so monitoring concepts are automatically applied to specific resources, automatic generation of graphs and dashboards, and so on. It provides auto-registration if nodes appears in your cluster and disappear. And it provides much more powerful trigger rules and mechanism than Prometheus. That's operations monitoring. So A second thing we implemented is the application and system analytics. It's based on the OpenSearch open source product. That is a fork of Elasticsearch and Kibana. Probably you know there were licensing issues in Elasticsearch some time ago, and this solution uses the Apache license and is free to use. It's on Apache license 2, and there's an active community which develops that system. It provides a distributed, scalable, reliable document storage, and it provides a powerful search and analytics platform and stores directly JSON documents in indexes with full text support with inverted indexes, and that provides great capabilities to do efficient queries and to work with data in a structured way. Also in contradiction, for example, than Grafana Loki. It provides the ability to do hierarchical storage management. So you can store the young data in NVMe disks. You can move them after some time automatically to spinning disks. And after another time interval, you can move them to S3 bucket to store them long term. It also supports multi-tenancy and index and field permissions. So you, for sensible fields, you are capable to only allow a small group of administrators to see specific fields. So how is that implemented in detail? It collects system logs, Kubernetes also Kubernetes events. And if we look at the architecture diagram, we have that fluent bit component, which is deployed on every node. And that fluent bit component collects all the logs which are produced by the specific node, and also the journal data sets. And these fluent bit software ships these logs enriched with some additional fields to a centralized or to a data center local Kafka buffer. All the data is stored in that Kafka buffer of the data center, and that provides the decoupling and buffering. On the other side of that Kafka buffer, you have that fluentd component. This fluentd component reads all the events written which are stored in that Kafka buffer and performs the detailed processing of these log messages. These fluentd consumers can be installed with multiple replicas, so scale out is not a problem. And you can also decide where you want to deploy that fluentd. You can add it to your cloud data center and put it on that location, or you can also put it in your centralized observability platform. That decides in which direction the data is shipped or transferred. Another topic is we will write a syslog shipper. If you have hardware devices like switches, firewalls, and servers, they do not provide the ability to install a fluentbit log shipper on them. So they have that classic syslog messages, and we provide a proxy which converts syslog messages to a Kafka log shipping. So that's an adapter. And all these components that also applies for the other components can be installed in different network areas. So you don't only have one possibility, you only have one component which needs to communicate to the outside world. So the third pillar is the application and system profiling. It's still in a very early stage. Currently, there's no technology decision for that, and only conceptual ideas. we will start the pilot implementation in the fourth quarter of 2026, and ideas and expertise are very welcome in that area. So, some information about the specific implementations, about the current state. We, for operations monitoring, we implemented a deep open search monitoring to understand that our log aggregation, our application and systems analytics platform is working properly. We performed a proof of concept monitoring for Mir, and we have basic log monitoring for Yahoo. What is remaining? We now start to implement metrics and alerting for Linux, OpenStack, and Ceph and Kubernetes. There's already a lot of work in the open source community for that areas and all ready to use implementations, but our approach is to use them and to improve them upstream to make them more reliable, because most of that implementations which are floating around are not always in such a state that they are really usable directly. We want to add intelligent node management. For example, if you are doing operating system upgrades in an automated way, that nodes are automatically put in maintenance. We want to implement a ticket system gateway. We want to add alert and shift management, and we want to add a GNMI gateway for network devices to monitor advanced network hardware. We also have to add a lifecycle management for Zabbix, Mir, and Prometheus. This is currently done in a manual way, currently not a big thing, but if we add more and more monitoring mechanisms, it's really important that we have an automated way for that. So when we look at the next pillar, the application and system analytics, what we already implemented is processing of structured OpenStack logs. With the Fluentd, you have the possibility to work over the delivered log messages, and we removed the binary garbage, did some formatting for OpenStack stack traces to make them more readable, and did also a lot of field mapping and indexing for these kinds of events. We also implemented processing of Kubernetes events, operating system logs, and so on. And we have dedicated indexes for structured and unstructured logs. And we have a fallback functionality for unexpected non-JSON or broken data, which is not parsable, that this data is not lost. And you are aware that you are probably skipping a lot of data to your regular index. What is remaining? Structured logging for all the operators. And we want to add ingress and generic ingress and gateway API dashboards, which help to analyze the HTTP request behavior of all the applications which run in your Kubernetes cluster. We implement that syslog to Kafka bridge and a lifecycle for the OpenSearch configuration. And the last thing, it's a small one, but a very cool one. I used in the past the logcli command for Grafana Loki. That is a command line front end for the log aggregation system. That helps you as a system administrator to read in a tail manner the logs of your OpenSearch instance. And this is very useful because you can add filters and post aggregations and automatic processing for analyzing problems which are not that good analyzable in a classical web interface. So we are now at the end. The perspective of the future is one of the most important next step is to add a strong testing framework to simplify the quality assurance of releases. We want to improve and implement service and solution-specific observability mechanisms, for example, deeper Ceph monitoring. We want to get the pending upstream updates into the product. We did, as I mentioned, we did some enhancements, and we also wait for things like the release of the OpenSearch 3 operator. We want to get feedback and refactor the current solution. We want to finalize, document, and enhance the lifecycle concepts. And we want to enhance the documentation extensively. We already have a lot of documentation, but that still needs some rework and improvement, and to make it more understandable for new users. We want to build a community of uMon adapters, and we want to globally add and document SSO, single sign-on support. We want to identify the integrated tracing solution, and we want to incorporate open tracing. So that's all. Some links. We will soon publish the documentation space, and this presentation will also be available in that area. I made that presentation with a new framework, Turing and types. That's LaTeX follower. I like that framework very much. I can recommend it. So that's all. Do you have questions?
Thank you very much for the presentation, Marc. It's really good to see how you've moved from specific principles to an implementation, technical implementation. It's a very good overview. If you have any questions, you can, some questions already in the chat, and you can also ask them out loud. So the first question from Michael: how does the project assess the challenges and uncertainties posed by the AGPL requirements regarding the potential disclosure of all components and in-house developments that may be monitored by the uMon stack or connected to it via interfaces?
That's a difficult question, but I'm not a lawyer. Yeah, if you AGPL version 3 software can be used in-house without a problem. It comes only to you have to look a bit deeper if you provide that if you make changes to that observability platform for your own organization and publish it to your customers. Then you have to ask your lawyers what you can do. But for typical scenarios of a cloud operator or a service provider, there's no problem.
Hi, Marc. That's Michael. Thanks for the explanation. But that's exactly the question around. So how this stack is used. So if you present the stack to the customer and the customer has access potentially, then this question unfortunately is quite a hefty discussion with the lawyers, and even they are not quite clear about. And so we also are not quite sure how we can use it and how we can connect it. Yeah, so you're right. If you have vanilla stuff you monitor, then it's probably not an issue. But if you already have changes to the stack you monitor, then there may be some issues.
So the principle of that platform is collaboration and putting your changes back to the upstream. When you do that, you have almost never a problem. So absolutely. It only applies if you, for example, if we implement such, if you fork the Helm chart or our implementation for specific services, if you fork a project and run there internally, then you might have licensing problems, but typically that is not the case.
Yeah, if all is open source, open cloud, then yes. So maybe for just putting that right. So I'm on the head of cloud engineering of the sys11, and we not only have public cloud, we also have very private, secure stuff based on our mother company Secunet. So we also have high secure cloud environments, and then maybe we are not allowed to open all stuff up, and so that would be a break in the chain where to use such stack.
If you make local modifications, then you have to publish it to your users. So that's also not a big problem.
Yeah. Okay. But thanks a lot. Very impressive stack.
You're welcome.
Maybe we need to organize a tech talk with a lawyer.
Would be great. Thank you.
So any other questions or comments?
I added my mail address or my matrix handle. So if you have any further question, don't hesitate to ask.
Great, thank you very much. So discussions can be continued afterwards. I see that someone is writing in the chat, so I'll just give it a few seconds in case it's a question or comment. Oh, thank you. Someone is saying thank you.
Thank you, Martin.
Okay, great. So if there are no further questions, then let's just move on to the last part of the Tech Talk with a very brief sharing of news and events. Thank you very much, Marc, again, for your great presentation. And now I will share mine again. So just very briefly, some news from ALASCA. So ALASCA has been at the FOSS backstage, and our colleague Daniel presented some general information on ALASCA and how the funding of the state of Saxony is helping the association to move forward. And there were some meetings between the members of ALASCA and also with the broader open source community. So that was a great event, as I've heard. And we don't have any photos yet, but I know that some of the ALASCA members have been this week at the CloudFest. I hope to see some pictures on that. Hope you had a lot of fun with the roller coasters and some interesting discussions among you two. And we would also like to let you know that this weekend, the Linux days in Chemnitz, so the Chemnitzer Linux Tage are taking place in Chemnitz, and ALASCA is going to be present there with a talk with this interesting name, Shift Your Focus, Digital Sovereignty with ALASCA. And there's also going to be a workshop on Taruk and yeah, how Kubernetes can be implemented with Taruk and help to provide an alternative to some hyperscaler providers. So if you're there, take a look at those talks and the workshops. ALASCA will also have a booth, so you can find our colleagues there during this weekend. And also just a reminder that the Sovereign Cloud Stack Summit has an open call for contributions right now. It will take place on May 21st in Berlin. So if you have any ideas, you can send them to the Sovereign Cloud Stack for evaluation. Does anyone have anything else to share? Any other events that we've missed? Any other news that we should know about? Then, as always, we have our ALASCA Summit reminder. We also have an open call for contributions, which will be open until the end of July. So please also send any ideas that you have for projects, use cases, any experiences that you want to share with open source based cloud infrastructures and projects. We're looking for short presentations of around 10 minutes, also longer presentations and also workshops. So you can please share and send your ideas. You can also register right now. If you want to secure your ticket for November, that's also open right now. So take a look at our website, and you can also use this QR code that you're seeing on the screen right now. And with this, I'm also done. Just know that we are always looking for speakers for the ALASCA Tech Talks. And if you have any ideas, then just send them to hello@alaska.cloud, and we will find a slot for you. And the next Tech Talk will be at the end of April, 24th of April, at the same time, always on a Friday, as you know. And we will have a presentation with a very interesting title. I guess also from NeoNefo, someone will let us know how sovereignty is a function of ecosystems and interoperability. So we're looking forward to that presentation, and yeah, also looking forward to all of you being present in April. So with this, we're done for today. Thank you very much, Marc, for your presentation once again. Thank you also to everyone who's joined us today in this Tech Talk, and see you in a month, I guess.